This tutorial is brought to you by PE Prep Engine. Free study guides and practice questions at peprepengine.com.
Week 4, Lesson 8, Belts and Chain Drives. A belt transmits power by friction. It carries a tight side tension and a slack side tension, and their difference does the work. A chain does the same job by meshing teeth, a positive drive, rated straight from a table. We'll size a belt from its wrap angle and the friction ratio, then read the chain method. All of it traces back to the power relation from Lesson 1. Concept 1. The friction drive. A belt carries a tight side tension and a slack side tension, and friction fixes their ratio. F1 over F2 equals E to the mu theta, with theta, the wrap angle, in radians. The useful output is the difference of the two, the net driving force, never one tension alone. That net force acts at the rim, so it becomes torque and then power. And slip always begins at the pulley with the smaller wrap, so the small pulley sets the whole drive's capacity. Concept 2. Power, torque, and speed, straight from Lesson 1. The rotary form gives horsepower as torque times speed over 63,025. The linear form is force times velocity over 33,000. And the SI form is force times velocity in watts. For a belt, the force in the linear relation is the net pull, tight minus slack, and the velocity is the belt speed. Concept 3. Belt geometry. On an open belt, the two pulleys turn the same way, and each keeps its own wrap. The small pulley gets pi minus 2 arcsine of d minus d over 2c, the large pulley pi plus that same term. The belt length adds the two straight spans to half of each diameter times its own wrap. Cross the belt, and the pulleys counter-rotate. Now there's a single wrap, and every d minus d becomes d plus d. Same skeleton, one sign flips. Concept 4. Centrifugal force. At speed, the belt's own mass is flung outward. A force Fc equal to mass per length times velocity squared. That force lifts the belt off the pulley, so it has to be subtracted from both tensions before the friction ratio applies. The faster the belt runs, the less net pull is left for real work. Centrifugal action quietly caps the power a belt can carry. Concept 5. Chain drives. A chain meshes teeth, so it's a positive drive, no slip, an exact ratio, no friction limit. Its capacity isn't a formula, it's a rated table. Take the horsepower you need, multiply by a service factor for shock, divide by the multiple strand factor, and that required rating is what you look up. You index the table by the number of teeth on the small sprocket and its speed, then pick a chain whose rated horsepower clears it. Setup. The worked problem. An open belt runs a 6-inch small pulley against a 12-inch pulley, 24 inches apart, with a friction coefficient of 0.3. The belt is allowed 600 on the tight side and runs at 2,000. We want the small pulley wrap, the slack tension, the net driving force, and the horsepower the belt can carry. Solve. Part 1. The small pulley wrap is pi minus 2 arcsine of 1/8, about 2.89 radians, or 166 degrees. Keep it in radians. Then E to the mu theta is about 2.4, so the slack tension is the tight tension divided by that, roughly 250. Solve. Part 2. The net driving force is the tight minus the slack, about 350. Feed that net force and the belt speed into the linear power relation, and the belt carries roughly 21. Use the small pulley's wrap. Leaning on the larger wrap would flatter the answer and overstate the capacity. Craps. 5 ways this bites. 1. Theta must be in radians. A degree value makes E to the mu theta wildly wrong. 2. Use the small pulley's wrap for capacity. The larger wrap overstates the pull. 3. F1 is the tight side, so the ratio is at least 1. Flip it and you divide when you should multiply. 4. Power comes from the net force, tight minus slack, not the tight side alone. 5. Open and crossed use different forms, d minus d versus d plus d, and chain horsepower comes from the table, never a friction formula. Quick recall. Friction sets the tension ratio, E to the mu theta. The difference of the tensions is the net force and the torque, and the power comes from that net force. Wrap angles follow the open or cross geometry, Centrifugal force trims the usable tension at speed, and chains are sized from the rated table. Golden rule: theta in radians. Use the small pulley wrap and take the power from the net force. Next up, Lesson 9. Clutches and brakes. Belts and chains carry power along the shaft continuously, but a machine also has to start that power, stop it, and hold a load on command. A clutch engages torque through friction, and a brake absorbs it. The same friction physics, a new job. Everything's at pprepengine.com. Cheat sheet, work solution, and a quiz attached here. If the course helps, subscribe.
The full study guide, with every equation and common exam trap, is free at pprepengine.com. Link in the description. Machine design, HVAC, structural, civil, and electrical series are coming soon. Subscribe so you don't miss them.